is any problem where we have a ramp. So when we have a ramp, we're always going to want to define our frame of reference with respect to the ramp. Specifically, we will want our positive y direction to be pointing perpendicularly up from the ramp, and our positive x direction to be pointing up the ramp parallel to that ramp. And the reason for this is that we want the three main forces acting on an object on a ramp are going to be the normal force, the frictional force, and the gravitational force. And of course, our normal force is going to be, in this situation, pointing directly up from the ramp. Our frictional force will always be pointing directly up the ramp. And so our gravitational force is the only force that doesn't easily fit into this frame of reference. Thankfully, it's actually pretty simple to figure out how to split up our gravitational force to fit that frame of reference. And the reason for that is that this angle between the y-axis and our gravitational force is equal to the angle of elevation of our ramp, which is given, of course, here by the symbol theta. As a result, we say that the force of gravity in our y direction is equal to our total force of gravity times the cosine of the angle of elevation. And in the x direction, it's going to be equal to Fg times the sine of our angle. So one thing I want you guys to notice here is that usually you're used to using sine for the y direction and cosine for the x direction. And with a ramp, we do switch that for the force of gravity. So let's go ahead and take a look at an example problem. So a box of mass 10 kilograms is placed on a ramp that is elevated to an angle of 30 degrees. The coefficient of static friction between the box and the ramp is 0.4, and we want to find the frictional force between the mass and the ramp. So let's go ahead and draw a picture first. Here is my ramp, and here is my angle of 30 degrees. I have my box with a mass of 10 kilograms sitting on that ramp. And drawing out my frame of reference, I can, of course, write that the positive y direction is up, and then positive x direction is to the right, also kind of up the ramp. And I can draw a free body diagram of all the forces acting on my box. So I'm going to have my normal force pointing up. I'm going to have my gravitational force pointing down, and I'm going to have my frictional force pointing up and to the right. So I know that my box is not falling through the ramp. So that means that my normal force must be equal to the gravitational force in the y direction. And this is going to be kind of the key to solving these ramp problems, is figuring out remembering that the normal force is equal to the gravitational force in the y direction always, unless the box is somehow falling through the ramp, which we know doesn't really happen in our regular day-to-day lives. Now, the other equation I'm going to need, of course, is that the frictional force is equal to mu times my normal force. So let's go ahead and start by finding my normal force, and then I'm going to use that to find my frictional force. So, for the normal force, I know that my normal force is equal to Fgy, therefore it is equal to my total gravitational force times the cosine of my angle. Thus, I can say that my normal force is equal to mg times the cosine of my angle, or 10 times 9.8 times the cosine of 30. And I know that my normal force is positive while my gravitational force is negative, because my gravitational force is pointing in the negative direction and my normal force is pointing in the y direction. So I can see that in my picture. So this means that my normal force is approximately 85 newtons. And now I am ready to find my frictional force. So I know that the frictional force is equal to mu times Fn. Thus, it is equal to 0.4 times the normal force of 85 newtons that I just calculated, and therefore my frictional force is approximately 34 newtons. And there you go. I have found my frictional force between my box and my ramp. Now, with this force, I could find a lot of things. So for example, I could figure out how quickly the box is accelerating down the ramp by looking at F equals ma in my x direction. There are other things I could do as well. So for example, there might be a problem where you're asked to figure out the angle at which the box will stop sliding. So there's a lot of questions here for y'all to figure out, but this is kind of the most basic part of basic thing you'll have to do to solve these ramp problems. So let's talk takeaways. So first of all, sometimes you have to use a frame of reference other than the traditional XY plane. So for an Atwood machine, we want one of our dimensions to be the rope. And for a ramp, we want our X and Y directions to be parallel to and perpendicular to the ramp rather than the ground. So we want to kind of flip our frame of reference so that it is in line with the ramp. And there you have it, folks. You now know how to solve problems with weird, ugly setups. So the rest of this is up to you. Best of luck and happy solving.